So we have a question here under trigonometric functions. Of course, it's a trigonometric identity. It says show that cos power of 4 theta minus sine power of 4 theta over cos power of 2 theta is equivalent to 1 minus tan squared theta. So how do we show this? So here's how we do it quickly, okay? Recall the difference of two squares. If I give you a to the power 4 minus b to the power 4, you can write this as a squared minus b squared, a squared plus b squared. So let's write this guy in the same manner. So get cos squared theta minus sine squared theta. Then you have cos squared theta plus sine squared theta over cos squared theta. Then slowly we can again remember this identity is equivalent to 1, this one here, meaning the entire part here is just 1. So 1 times this will just remain with what? With cos squared theta minus sine squared theta over cos squared theta. I can write this as, since cos squared theta is dividing throughout, I can write this as cos squared theta minus sine squared theta over cos squared theta. And this will give us 1 minus, recall all of these are squares, and recall that tan theta is just equal to sine theta over cos theta. You know this identity, right? So if all these are being squared, meaning even tan shall be squared, meaning we get tan squared theta. And this equals the right hand side, which has been given here. Hence shown, right? Hence shown. That's all.